Hello and welcome to the last section of the Unit 12 notes. So this section is going to have a bunch of properties about chords, or it's all about properties of chords. It's going to have a bunch of theorems. We're going to use most of those theorems in a couple different examples towards the end of the notes. So first I'm going to jump right into some review. So this is a diameter of a circle, so it's basically a chord that goes through the middle of a circle. So it has two endpoints on the circle, goes through the middle, center. That forms two different semicircles. So those are each, the yellow and the green are each a semicircle. This is just a chord, and it will form a minor arc. And, if I can get this, there we go, a major arc. So remember from the first section, minor arc just means that the arc is less than half of the circle or less than 180 degrees. Major arc is more than half or more than 180 degrees. So our first theorem that we're going to talk about says that if we have two chords in a circle and they are the same length, that's what this little symbol means, then their corresponding or their intercepted arcs, so these two green ones, are also congruent to each other. And the converse is also true. So if I knew the two green arcs were congruent to each other, then that means these two chords that intercept this arc, or each arc, has to be congruent. So I know that was probably confusing, but we'll get to an example eventually. Another theorem that we have is if we have a perpendicular, so I know these two lines are perpendicular because they form a 90-degree angle. So we got a perpendicular bisector. SQ I can tell is a perpendicular bisector because we know it's perpendicular. The reason I know it's a bisector is because that TP and PR are the same length because of this little symbol. So that means SQ is a perpendicular bisector of TR. So if that's true, then QS must be a diameter. So now we know that QS is a diameter. So anytime you have a perpendicular bisector going through a circle, then that perpendicular bisector has to be a diameter. And then the next theorem says that this chord, so AB and CD, have to be congruent to each other if, let's use a different color, I'll use gray. We have two little lines from the center, so EF and EG. If those are congruent or equal to each other, then the two blue chords have to be congruent or equal to each other. So if we have a little line here and it forms a 90-degree angle, a little line here forms a 90-degree angle, these two blue chords must be congruent. Same is also true if we have two blue chords that are, if you know the two blue ones are congruent, and from the center, these form 90-degree angles, then we know that EF and EG have to be congruent. So in example 1, if the measure of arc AB is 110 degrees, find the arc of BC. So notice that AB is 9, BC is 9. So what does that tell us? If these two blue chords are congruent, what does that tell us about each of their intercepted arcs? So arc AB is 110, so arc BC has to be congruent. So this would also be 110 degrees. So 110 degrees. So next, find the measure of arc AC, or if the measure of arc AC is 150 degrees. Erase all this. So 150 for arc AC. That's 150 degrees. to find the measure of arc AB. Well, again, these two are still congruent, so AB and BC are still congruent. So that means each of these orange arcs has to be congruent as well. If the entire thing, the entire orange arc here is 150, then just to find one of those, one half of those, 150 divided by 2 would be 75. So that means arc AB has to be 75 degrees. Moving on to the next page. So another theorem that we have, actually it's kind of similar to one that we talked on the last page, just talked about on the last page. So if we know this is a diameter, so e.g. we know it's a diameter because it goes right through the middle of the circle. If it's perpendicular to any chord, so FD is a chord here, and as we can see, the diameter and that chord are perpendicular. If that is true, then we know that FH and HD have to be congruent, or in other words, EG is a perpendicular bisector. So anytime we have a diameter and it forms a 90-degree angle with any chord, the diameter is a bisector, a perpendicular bisector. So that means this segment and this segment have to be congruent. And on the previous page, the converse of that was true, so the reverse was true. So example 2 says find the measure of each indicated arc. So CD, I need to find the measure of CD, this blue arc right here. So it's 9x. We have, let's see this red, a diameter because it's going through the center of the circle, perpendicular to a chord, which tells us that C, or this segment, and this segment are congruent. That also tells me that each of these blue arcs are congruent as well. So that means 9x, let me do it over here, has to be equal to 80 minus x. So if I solve for x, I'm going to add x to both sides first. I'll divide by 10, so x equals 8. So if x equals 8, 9 times 8 is 72. So that means CD, the arc CD, has to be 72 degrees. Now arc DE is this one right here. So we could plug in 8 for x and do 80 minus 8, which would be 72. Or I know that the two blue ones have to be congruent. So DE has to also be 72 degrees. And then CE, come on, this was 72. So CE is this entire arc right here, from all the way from C to E. So CD was 72, DE was 72. So I could add those two together and get 144. So CE is 144 degrees around that arc. Example 3. So we got QR is 16. So QR is 16 right here. ST is 16. We got to find CU. So we know that these two orange arcs, or excuse me, we know these two orange chords are congruent because they're both 16. And these are 90-degree angles, and these lines are coming from the center. So that tells us that CU and CV are congruent to each other. So 2x would have to equal 5x minus 9. So I'll subtract 2x on both sides. And I'll add 9 to both sides. And divide by 3 on both sides. So x is equal to 3. But hold on, don't stop there, because they did not ask us to solve for x. We had to do it, but we are not done. So CU is 2x over here. So CU equals 2x. but x is 3, so CU has to equal 2 times 3, so CU is 6. And then finally our last example. So ST is 32, and CU is equal to CV. So CU and CV are congruent, they're both 12. And then I got to find QR. So if I know these two purple ones are congruent, they're both 12, and they form 90-degree angles with these two chords, what does that tell me about the chords? They have to be congruent. So this is 32, this would also have to be 32. So QR is going to be 32. QU is just half of that, so half of 32 would be 16. And then finally to find the radius of the circle. So radius is just anything from the middle to the edge of the circle. So if I draw a little radius right there, I'm going to take this little triangle that I just made and draw it out here. So this is C, this is V, and then this is T. So CV I know is 12. From V to T it's 16 because this whole blue chord is 32. So from V to T that's just half of 32, so that'd be 16. So now I have a right triangle. I know the two legs, but I don't know the hypotenuse. So now we're going to use our good friend the Pythagorean theorem. So 12 squared plus 16 squared is going to equal C squared. So 144 plus 256. If I combine like terms, I get 400. Take the square root of both sides. The square root of 400 is 20. So CT is 20, or the radius is 20, however you want to write it. And I know I did not do plus or minus here, which I should have, but since I'm trying to find the radius, you can't have a negative radius, so we're just going to use the positive. And that's going to do it for the notes.